Okay, hi everyone. So in this video we're going to be looking at building a blogging server that uses the Archain as a permanent data structure on which you can write your interesting thoughts and ideas and know that the data will stay there indefinitely. So this is actually very simple and I'll take you through it. So the first thing we're going to do is we're going to create another file, Erlang module. We'll call it app_journal this time. Journal, blog, doesn't matter too much. Module, app journal. So again, just telling Erlang what the name of the module is. Now this time we're going to have a start function that takes a single argument, followed by a, what should we call it? Well, we'll have a message function, which takes 3 arguments, and a new post function, which will take, let's see, 2 arguments, I'll say. No, 3 arguments. Okay, good. So we need to include the header file again, so ar.hrl again, so that we can access the transaction record structure. So we start, we implement the first function, which is the start function, and here we're taking 1 argument, which is a list of peers. And what we're doing here is we're going to connect essentially our journaling app into a network of Archain nodes, and we'll start the ADT simple system with that list of peers. So we'll say module and then some state, which we will fill in a second, and our peers. So now comes the state, which is how we're going to authenticate. Well, it's part of how we authenticate ourselves with the journaling app. So essentially what the journaling app does is it's a server, most probably going to be a web server with a front end on top of what we're building here, which will use the new post function. And it'll allow us to write posts, if we are the owner of the server, have them signed and sent onto the network. So what we need to do in order to do that is create ourselves an identity, and we do that by creating a wallet. So the wallet returns two values, the private key and the public key, and we get the new wallet by saying AR underscore, so AR underscore, the prefix we use for all of the Archain modules, wallet colon new. Let me just check that, in fact. So we'll start the Archain environment by saying /stroke Archain server, and this is useful as it shows you how you can have a look at the API while you're programming. So indeed, new with arity 0 is how we access that functionality. Okay, brilliant. So this is going to return a process identifier, but our start function is a little bit more complicated than our other ones. So we keep this process identifier. So this is the process identifier of the new ADT simple node, which is going to call back to this function. So again, question mark module evaluates to the name of the module, and that's because we're passing this as the callback module to call when you have a new message event, for example. So the state that we're going to keep in the server this time is the public key. And then we're going to return to the user the private key, as well as the process identifier. So now we're going to implement the message event handler, and the message event handler is going to take the state as the first argument, which is pub key, and the gossip state. Now this we'll get to in just a second, as well as the yes, the message itself, which will be new post, private key, and the text. So here, this gossip state that I mentioned is essentially the way that your Archain ADT simple applications can send messages to the network, the wider network in which it's embedded. And again, we do this without having to create a complex server structure. We can just receive the gossip state. The only complication this really adds is that you must pass back the new gossip state, which changes every time you send a message to the server, or rather to the Blockweave network, when the function is finished. So what we do here is we first say create a new. We'll create a new transaction. So we'll say t equals artx new, and we will give it the text that we've been given. Now this text is as a bit string, but we'll get to that in a moment. Next, we'll have the signed transaction, which we can derive by calling ar_tx sign. Let me just check that. So we go to the terminal, tx, and we'll have a look. So we press tab, and sure enough, sign is the function that I'm looking for. So this takes the public key, the private key, or rather the private key, the public key, and the transaction to sign. Then we collect ourselves a new gossip state from the execution of the following, which is ar_gossip. So in the gossip library, which is how we send messages again to the wider network, send. So it takes the previous gossip state, and this is contained in it. It has all of the peers that we know about, amongst other information. And we send it a message that just says add tx, and then we give it as signed t. And oh, well, why not? We'll okay, so we'll define a tag for these types of journal messages as well. So we'll say journal tag is journal post, something like that. So now we're looking, now when we submit things to our chain, well, we'll set the tagged t equal, we'll be able to find the journal post later by just looking for transactions that are tagged with journal tag, the journal post here. So we say t hash tx tags, or rather, sorry, tag. So here we're modifying the record. So if we'd said hash tx tags equals a list with one element journal tag, then this would have created a new journal, a new transaction record. But if we simply add t beforehand, now it's going to modify, or rather make a new copy with the modifications that we have here. And we'll call this tagged t. Now, the reason that we're not just reassigning these variables to t again is because Erlang has immutable data, or immutable variables. So you can't edit the contents of a variable after it has been assigned, which is actually much closer to how things are in mathematics, but we won't get into that now. So here we take the tagged t and we sign it, and then we call that signed t. And then we send it around the gossip network. And the final thing that we need to do is just return the state, but this time, because we've got the application state as well as the gossip state, the new gossip state, we need to return a tuple with two elements, the first being the public key, unchanged, and the second being the new gossip state. And so now we have a way of getting these messages onto the network. And so essentially all we have left to do is to create a function called new post, and this is how the user is going to interact with the server directly, and they'll just give it the PID of the server they're going to interact with. So this is the app server, and the private key, as well as the text that they would like to post. And so all we do here is we send a message to the server. So PID bang, and this is the operator for send in Erlang, a tuple, new underscore post, private key, and text. And that's all that needs to be done. Now the one thing I'd just like to, yes, we don't have the question marks in front of that. ADT, whoops, ADT simple start, sorry. There we go, right. Yes, and so there's just one thing I'd like to check there, which is that public key is indeed, or the signing order is like this. So I'm going to open up ARTX and check here. So we take the transaction first. Well, I would have got that wrong. So we take the transaction first, and then the private key, and then the public key. So that's fine, we'll go back. We'll say, take tagged t as the first argument, like this. Okay, brilliant. So now we run AR rebuild, and that's built our journaling app. And now we'll build ourselves a network. So peers equals AR network. So start a network with, why not, 10,000 nodes this time. 5 connections for each node. Give that a second to run. Good, so now we've got a simulated network of 10,000 mining nodes. We're also going to make ourselves a stock app node, as we developed in the first video. And this is going to show one of the more interesting parts of the Archain. So we'll start it as yes, there we go. So we start, and we'll say we're looking for more stock information about Google for some reason. Okay, fine. So that's set up, and now we add that peer to, say, the first node in the network. So we'll take the first node there. We add the stock app, but of course it could just as well be any other node. Oh, I meant add peers, although add peers does take single peers, as well as lists of peers. So now we've got ourselves a network with 10,000 mining nodes, and we've added a stock app monitor, essentially, that's going to listen for talk about Google. And now we start our app journal. So this is going to return to us our private key that we need to keep safe so that we can identify ourselves with the server. And the process identifier of the app journal. So we'll call that, we'll just call it app journal, why not? App underscore journal start. And now we'll give it the first, I don't know. Okay, we'll give it all of the nodes. So this app journal is going to be connected to every single node in the network. Good. Right. So now we send app journal a new post, or rather we use the new post function in the app journal module to interact with the app journal instance that we just created, the app journal process, which is running the ADT simple node type, but it's calling back to our module here. So when it receives a message that isn't part of the gossip network, it'll call this message function. So we say app journal, give it a private key to identify ourselves with, and I don't know, I thought about buying some Goog shares today. I didn't, but we'll pretend we did. So we send this, and we can see here that this blog post has been sent to the network, and sure enough, the app, the stock picker app has picked up that somebody on the network has written a journal post about how they nearly bought some Google shares today. And sure enough, it's reported that the buy support there was 1 and the sell support 0. And so here we see the interaction between the different types of users of the chain. Some people might like to post their thoughts about the day, and other people might be able to mine that data in a perfectly friendly way. Yes, for useful signals about the world. Yeah, and this shows the interactions between the different types of people and different types of apps on a chain. And of course, if the user wanted to make the journal post private, all they need to do is use the Erlang crypto module to, let's see. Well, I won't implement it now, but, well, here we go. Encrypt their data with the appropriate key, and then they'll be able to store it on the chain, and it'll be retrievable using their private key that only they have at a later time, and so it won't be accessible to people that are running, say, nodes that are looking for information about stock advice or stock related sentiment. But that's totally up to the user. Okay, I hope this has been useful. Thanks.